What's up, everybody? How are we doing? It is review time. Good to see you here, Mohammed, Charlie, Paige. Remember, Mubot can't see you if you don't talk. Mubot, where you at?
I am here. If people don't talk, they don't get points. Like when I say 50 points. Whoa, 50 points. If you're not talking, you're not getting those points. I take away your points.
Mubot, that's mean. Don't be mean, Mubot. Good to see you here, Kevin, Charlie, Avery. Good to see you here. Yes. Got so many people here earning those points. Margaret, good to see you here. What's up? Ian, let's go. Rachel, good to see you here. Everyone's saying hey in the chat right here. Coop's saying, oh my God, not that laugh. Good to see you here, Hunter. Good to see you here, everybody. Let's get started up. We're going to load up the activity for the BAS 320 class. But I invited 474 to this also. I hope no one minds. But I invited 474 to this because what we are covering is for loops. Now, we're going to start this in class tomorrow for both classes. And we go a little bit more in depth with the 474 class. But, sorry, my sinuses, no. It's one of those days. Everything's just going crazy. We got right here the activity for the 320 class. We're getting it downloaded. Let's show this right here. We're just downloading in the background right here. 2 seconds. I'm back. There we go. Good to see you here, Hunter. We got here the R programming. You can't see it. Let's show it in the background right here. I'm just downloading main screen. Downloading these things right here. Download. Don't download the solutions. Watch this. You go here. You go. Oh, wait. This document cannot be displayed. Good. There we go. Can't do display. That's what we want. Leave student view. Let's go take a look right here. Leave student view. And let's go right here into the R programming. Now, with this right here, we are solutions. It says solutions, but they're not solutions. Slowly losing my mind. Who else? Put yo in the chat if you're losing your mind. Be like, yo, who else is losing their mind? Semester's going crazy. Internet's going crazy. If you're losing your mind, if it's been a crazy semester already, but you know what? We're almost to a 4-day weekend. Hey, Lucy, good to see you here. Paige says, yo. Scotty says, yo. Angela says, yo. Yo for sure, says Coop. Yo for sure. Crazy semester. Crazy, so much stuff going on right here. Yo. Who cannot lose their minds? That's a good question. Who cannot lose their minds? It's all right, though. It's all right. We got this going on. So what we're talking about here is how to write for loops. Internet has been Internet's been horrible. I agree. Couldn't agree more. Definitely was talking to one of the RAs on campus who helps on our Discord, and he was saying, Internet's been really bad. Internet's been pretty bad lately. Sorry about that, everybody, but you know what? This is recorded, so check it out later if you miss it. What we have going on right here is we are loading in this. Now, what is wrong? This is a common error people have. What is the error people have when you run this load thing right here and it doesn't load? Like when you see this right here, and you do this, and it says, that's a common error people have. What is this? Explain to me this. If you run this problem, you run it, and you're like, it's just not loading. Thing is not loading. Let me try it again. The file is not in the working directory. Lucy right there, 20 points. You are correct. The file is not in the working directory. I changed the name of this right now. Make sure your files are in your working directory. You can see right here, this will load the environment. What is an environment? An environment is a brain for R. This is an R brain. So when you load this environment right here, this is an R dat file. An R data file is a brain. So you could actually save it right here, going to the save, and you'll just save the brain of R. You could load a brain. So you can actually load a brain. It's a workspace, but it's environment. The brain, it's the brain of R. So you're loading it in. You can just Dumbledore out all that information right here. Just take it out. There we go. We've erased the brain. But now we can load back the brain. You have a brain, you don't have a brain. That's just the way it goes. Loading and unloading the information. It's just taking this data and putting it into R right here so we can see what's going on right here. The brain, if I only had the brain. So this is what we're going to be working right here with. We're going to be working with some New York Stock Exchange, cost matrix right there. It looks like a cost matrix. Some acquisitions, a function called crack right here. Facebook, all these great things right here are different things we can be working with. Let's see down here and learn about for loops. Tonight's talk is all on for loops. So if you are in 320, this is the first time you're hearing for loops. If you're in 474, you're here for a great review, and thank you 474 for showing up. When we do for loops, this is where people are like, I don't know how to do a for loop. Matthew, email me. We'll get that working. Email me quick about that. I was trying to catch up on emails. Fruit loops, not Fruit Loops, but for loops. You probably have something printed on your thing that we need to delete. You can always edit your Word document. DataCamp had while loops, and I got confused a little bit. We could look at while loops at the end. That'll help 474 a lot. So take a look. A basic for loop. Although setting x equal to be the sequence 5, 10, 17, 101 is easy, with x store into, we're just going to grab this, and let's write it. Oh, take a look. Well, all this does right here is why do we get multiple... Can anyone explain? Take a moment. I want you to think, why do we get multiple values of x's? Why do we get these values right here that are multiple values of x's? Why do we get multiple values of x's? Like, why didn't it just give us one value? Like, if I usually do something like x save into 2 plus 2, x is now equal to 4, and I can check it. Why are we getting multiple values of x's right here? Yes, Charlie, you are exactly correct. Charlie, another 20 points. Charlie is very correct. Charlie's pointing out here that this is a vector, and we're doing vector mathematics on it. Great job, Anjali, also. Because there's a vector inside of there, it's doing it for each element of that vector. So we're going to change this up a little bit right here and start doing this with a for loop and talking about what a for loop does. And so these questions progressively get harder. So please watch from the beginning as we start talking about the basics of a for loop. So we're going to make a for loop to do this in a moment, but I want to show you what a for loop is. This is what a for loop is. When you want to write a for loop, you just write what? Put it in the chat. Show how you know how to write a for loop. I don't suggest writing it all out. Use the snippet. It's going to do it for you. You can write it all if you really want. Great job right there, Kevin. You're going to write, and Lucy's pointing out some vector mathematics we're just done. Correct, Lucy. Great job. I would not suggest writing this all out. You just write FOR, and you hit enter. That's it. So you look at all this stuff right here that I can write. Watch. I'm a speed writer. I'm going to go right here, FOR, enter, and then boom, I've written all this out. That's like 200 words per minute. You're not going to type that fast because I can't type that fast. Maybe you can, I can't. So this is going to do a lot of that work for you. There's other things that also do this, like F is for friends who do stuff together, U is for you and me, N is for anywhere and anytime at all down here in the deep blue sea, and this is a function. So this wrote the function for us, or we could write while, if we knew how to type, and we can write while, and it gives us a snippet for the while. We're not going to use those snippets right here, but a snippet is basically creating the container for you for a for loop. Do not write these out by hand. I mean, you can if you want, but why not just use what they give you? Nice and easy. So what is this? What is a for loop? Well, let's talk about how a for loop runs here real briefly. A for loop is going to do the following. A for loop is going to take right here a variable, which is just a placeholder. Musical moments. And the variable right here, let's actually draw one first. The variable can be any name at all. What is a variable? It's just a placeholder. Any name you want. Someone give me a name for this variable. 474 is going to know some classic names, but nothing you say right here is wrong. Some SpongeBob. Anything you call this variable is fine. Anything you want. We can call it anything. Literally. I probably wouldn't call it this. That's a little much. Brian, you're being a little crazy right here. You can call it Brian, I told out. You can call it Brian. What else? We can call it anything we want. Anything. We might want to be careful with the exclamation point. Don't worry, I think Lucy was just saying anything, exclamation point. We can call it lol. It can be called that. Let's try this. Brawl. We got some classic brawl in the chat right here. We'll call it lol. We knows out some brawl. He's over there on the other side of the camera. So now what is a vector? Wait a minute. Is that a vector? Yes or no? Is that a vector? A sequence can be a vector. No, this is a vector, though. This is a vector. It is a vector. I'll just call it vector. Now it's called vector. And if you look down here, it is a vector, an integer vector from 1 to 9. It is a integer vector from 1 to 9. So let's just go right here and put the thing right there. That's just a sequence. It's a sequence, an integer vector sequence from 1 to 9. What's the point? So we have something, we just called a name, and then we have a vector of things, and now we need one last thing. Who knows? And if you're in 474, you'll know the answer to this, and it's a good review. What is the inside sandwich of our for loop called? And I'm giving you a hint right here. You're going to hear this terminology a lot tonight. You'll hear me referring to it. What's Brian saying? You're like, 474 knows this is how I talk about it. It's your inside. What is the inside? I got Muhammad up right there. I thought I'd pause the stream. What is the inside? It is the bones, and your bones is in your what? You got this right here. Your bones are in your what? It's the inside of a for loop. It's the skeleton. Charlie right there, and Muhammad earning everyone 50 points. Great job right there. It always changes. I need to change my hotkeys. This is the skeleton. You know what happens? Your skeleton never changes. You could call it like the bodies, different ways to call it. It's the code of the function. It's the skeleton, and the skeleton never changes. So the skeleton will remain the same every time we run it. That's a huge note to take, is that every time we run this for loop, the skeleton changes. But I want you to see what happens right here, and let's do a very simple one, and then we'll do this one up here. I'm going to go here to print lull. What do you think? And for those who know how for loops are run, can you tell me what this for loop's going to do? You might even be able to deduce it because it doesn't have many options. What is print lull going to do? And that's the code inside of there. Every time this runs, it's going to print lull. But what is lull? And then we're going to draw what this looks like on a Word document. We're going to draw it out to visualize what's happening here. So print lull. It'll print everything 1 through 9. Great job right there, Coop, earning another 20 points. It'll print it'll print everything 1 through 9. So let's look at how it does this and why it does this. When we run this code right here, it's going to print lull. But what? Well, it printed 1 through 9. Well, that's what we wanted it to do. Let's draw this out and understand what the for loop is doing. This for loop right here is running a total of 9 times. When this for loop runs, the very first thing this for loop is going to do is do what? It's going to assign 1 into lull, and then it'll do what? What does it do after it assigns 1 into lull? It's then going to, and maybe I should go this way, print lull. It's going to execute the code. It prints lull. And it doesn't print 1. It's not printing 1, right? Make sure you have this right here. I'll drop this in the chat, Avery, for you. Let me drop this in the chat. This should work right here. That should work right there. It's not going to print 1. It's going to print lull, but lull is 1. Well, what happens when the code then circles back up here? When the code circles back up, what happens now? It's going to save into lull what? Now when it circles back up, it's going to save 2 into lull. And then it's going to circle down and print lull. And then the next time it's going to do what? It saves lull into 3. It saves 3 into lull. So 3 is the next time, and then it prints, and it's going to keep doing this, circling around and around and around, till the last time it runs, it saves 9 into lull, and then it prints 9. What about if we did this? Here's a little bit more complicated version. If I were to say, let's say, this is a little more complicated, cat paste the members of my family, or blank is a member of my family. Okay. And if I were to put here Darren, does everyone see what that does? Does that make sense? This code right here just says Darren is a member of my family. Oh, not right now. We're just doing the activity. Great question right there, Edgar. I can find you a video on that if you want, Edgar. Thank you for asking, Edgar. So you see what's called loop. Great job right there. Awesome work. Does this make sense? It says Darren is a member of my family. I'm going to add one last thing right here. I believe, I always get this wrong. No, it needs to be the special character inside of here. Cool. Now I want you to see this. You ready? That's a special character that starts a new line. Don't worry. I just use it sometimes. If I go right here and I run this as is, let's do variable. Give me a variable name. It can be anything we want. It's just a placeholder. It's just a placeholder. Anything you want. Doesn't matter. Rock, what do you think?
Wow.
No, that's not Rock.
It doesn't matter.
There's the Rock. Lucy? Morty Bunny? I like Morty Bunny. I'm going with Morty Bunny. He had to go to the vet yesterday. Poor Morty Bunny. So there's Morty Bunny. You should be a member of our family too. Now, Vector. Now, here's the issue. What is this going to do now? It's going to assign 1 into Morty Bunny and then run the code. It's going to assign 2 into Morty Bunny and then run the code. Do you see the loop? It's going to run 3 into Morty Bunny and then run the code. It's going to run 4 into Morty Bunny and then run the code. It's going to run 5 into Morty Bunny and then run the code. So what's this going to do? Remember what it's going to do. Just think about theoretically for a moment. It's going to assign 1 into Morty Bunny, then run the code. 2 into Morty Bunny, then run the code. 3 into Morty Bunny, then run the code. Lucy's correct. Morty Bunny is not in the code, so it's going to do what every time? The code is static, right? Do you see how the code doesn't change? So just think theoretically for a moment. I'll repeat again what it's going to do, but I want you to think about it. Not quite an error. I don't think we'll get an error. Good Paige, good guess right there. Remember, it's going to assign 1 into Morty Bunny, run the code. Assign 2 into Morty Bunny, run the code. 3 into Morty Bunny, run the code. So it's going to run the code. Do you get it? It's going to run the code with the sentence speed errors. It's going to run the same sentence 5 times. Do you see it? But what about if we replace Darren with Morty Bunny? No, I want to point something out. I want to slow it down. What's the difference between Darren and Morty Bunny? Notice a key difference. Like Darren looks green. Sorry, Darren, you look green today. Morty Bunny looks like that. And Morty Bunny is just any name we want. We just chose that randomly. What's the difference? Whoops. What's the difference between Darren and Morty Bunny? And why is it a different color? Key things to know right here. We're doing little bits. Why is that a different color? Oh, Darren's got something around it. Darren is a what right now? Darren's in quotes, making Darren a string. Great job right there. And Logan, great job. 20 more points. Following along. Morty Bunny is part of the loop. It's an object right here. And so now, what is this going to say? Who can tell me the first thing this will say when I run it? So the first line of code this will say, remember, it's going to assign 1 into Morty Bunny, run the code. Assign 2 into Morty Bunny, run the code. Run 3 into Morty Bunny, run the code. Logan right there. Amazing work, Logan. 1 is a member of the family. 2 is a member of the family. 3 is a member of the family. 4 is a member of the family. Because it's just replacing whatever Morty Bunny is with 1, or 1 is being assigned to Morty Bunny. Then it's executing the code, and Morty Bunny is currently 1. If you look in the brain of R, you can actually find Morty Bunny. There he is. Morty Bunny's currently 5. If I change this to 10 after the loop runs, Morty Bunny is currently assigned to 10 because the loop assigns that value to the variable. The variable is just what's going to take on that value. Does this making a little more sense how this is running? Like the first time it runs, it assigns 1 into Morty Bunny, then runs the skeleton. Then 2 is assigned into Morty Bunny, then runs the skeleton. How are people doing? Please slow me down if need be. Loops are a little tricky. Try writing them out. We went from a very simple one to a little more complex. Because what about if I do this? Let's not use numbers. We don't have to use numbers. The skeleton never changes. Every time we run this, it always runs the skeleton. So now it says Darren is a member of the family, Brian is a member of the family, Emily's a member of the family, and we just run right here because all it's doing is running this code that prints to the screen Morty Bunny as a member of the family. Every time this runs, it runs the same code, but what changes? What changes? The skeleton doesn't change. I'll give you a hint. I'll put things on the screen. What changes? Every time the code runs, what changes? Every time the code runs, what changes in the code? Not the skeleton. Skeleton's always the same code. What is stored into Morty Bunny? And so what is in the variable changes, and it moves to each new position of what's in the vector. So we go from the first thing, run the code. Second thing, run the code. Third thing stored into Morty Bunny, run the code. So the variable is going to change through the elements of the vector. And I'll repeat it once again. When the code first runs, it stores Darren into Morty Bunny, runs the code. Then it stores Brian into Morty Bunny, runs the code. Stores Emily into Morty Bunny, and then runs the code. And repeat after me. What Does it matter what we call this right here? If I call this family member, does it matter what I call this? Does it matter what I call this? What's the answer? Does it matter what I call the variable? Does it matter? I don't have live chat on. Oh, do I? I do. No.
It doesn't matter.
It doesn't matter. It'll run either way. It just needs to be referenced the same. Could you remind us of the uses in real life for loops? Oh my gosh. The uses for loops in real life are so... has everyone ever used a loop outside this class? Because one thing I was working on with a student, we were working on scraping MLB web pages, and we had to get player data. So they looped through all the MLB web pages to scrape all the data. And so they ran a code that took the player data off a web page, and then they just looped through all the web pages. I had to write a crazy nested loop. Where's my regression solver pro? Do I have that? 2 seconds. I think I've got some loops in there. Where's my regression solver pro? No, that's the wrong one. I've written some crazy loops. And where did I post this? 2 seconds. Let me go get my regression shiny app. Here it is. Sent it to someone recently. Oh, I don't want that one. Oh, here's Petrie. I sent this one to Petrie. Okay, good. So the usage, why we would use loops. The whole point of running a loop is so that you don't have to run the same code multiple times. So for those in the shiny class right here, this is 300 lines of code or so. And right here, you see a for loop right here, a nested for loop right here. I'm trying to remember my code for this. This right here. Oh, this is the all correlations. Oh my gosh. This code right here, and I'll show you what it does. This code right here was going through and running the all correlations. And I had to go through and do all the correlations, I think, for every variable. So let me get a data set loaded in right here real quick. So for those wondering if you're in the shiny class also, I'm going to load up a data set right here. And why would you use loops? Where is the survey data? There it is, survey.csv. Oh my gosh. 2 seconds here, everybody. And then we're going to do the next question. There we go. Here we go. Is it working? Investigate. Whoa. My code is having issues. That's never good. Part of it's working. Okay, there it goes. Okay, it's working. It's working. Okay. So if you notice right here, I do once a week pretty much. Do laundry and then Vault for Life shirt comes out again. They can also take the mean and median of multiple. So with this right here, this is my nested for loop right here, going through and doing all the correlations for each variable. So this right here uses the nested for loops, I think, because I didn't have a quantitative variable. This is a shiny app I created right here to run all possible correlations and everything, create the distributions, create the scatter plots, the model summary, the data table of everything. So this is kind of what you're doing if you're in 475. I don't expect you to do something of this, but look how we have a scatter plot, the bivariate or the both histograms for it, and then also here we have my nested for loop making this output. So in other words, this right here is being done to run all correlations on every single variable and creating this table. I think then I sort the table, but for loops are widely used to run code. And let's go look where else I use for loops in this. There's for loops again. That's not a for loop. Format, not for loops. So it's only up here at the top when I'm doing my all correlations. I do remember using for loops for this. And we're only doing the correlations on the variables that are what? Good review for 201. We're only using the correlation on variables that are what? Because I tell my 201 students to do this. We only do correlation on what? And for loops save time. We're only doing it. And actually, you know what? Or, you should see this also. We're only doing it if it's numeric or integer, which is quantitative, because correlation is for quantitative relationships. So this right here is only doing it pretty much on every quantitative combination. Whew! Takes a while to write the code, and you get all these packages I've loaded in right here. So why do we use for loops? Lucy said it perfectly, to save time. If you have something you want to do repetitively, which we'll see right here, Writing a for loop allows you to do code, but do it tons and tons of times. Like, let's say I wanted for my nephew Tolliver, and this is the last example before I start doing every question. If I wanted to go through here and create something where I said to Tolliver, let's say I were to ask him to go here and print out, let's say 9 times 1 is equal to, we got to put it in words. So 9 times 1 is, and then let's put here, and then we'll put here 9 times 1. Let's check to see if this code works. 9 times 1 is 9. 9 times 1 is 9. Tolliver throwback. Yeah, he's in kindergarten now. He's getting old. No, he's driving a car like next year or something. 9 times 1 is 9. 9 times 2 is 18. But now watch this. What do I want to change every time I run this code? Do you see what is changing? This is key. What is changing every time I run this code? The skeleton will just be dependent. Well, the /n, this right here, the /n, that starts a new line. That's a string character for new line, special character, new line. Great question, Muhammad, 20 points. So the /n is a special character if you do multiple lines right here. If we go like cat, paste, and we go hello. Oh, there's hello. And then we go \n, and then we do Brian. We should get hello, Brian. And so \n starts a new line. Great question, Gavin, and also Muhammad. That's a special character that starts a new line. Not super important, but good for making syntax look good. So that's a special character that starts a new line. Without the \n right there, we would not get that new line. So hello, Brian would just print hello, Brian, which maybe we want it to look like this, but the \n is a special character for new line. Great question. Thank you, Muhammad, for asking. And does everyone see Lucy's pointing out the third and the fifth argument are changing? So maybe that means it needs to become the what? The third and the fifth argument maybe need to become what because they're changing in the skeleton. So if you're understanding this example, you're understanding how to do for loops. The third and the fifth that are constantly changing when I run this to change this probably need to become the what? The third and the fifth that are changing, because if I run this code and want to say something different, I have to change this. So those probably need to become the what? The variable. Great job, Lucy, right there. How about we just call this I? Now the variable needs a what to go through, because this probably won't run. It's going to break. Now we need for the variable, which is I, to go through what's. We need the variable that is I to go through a bunch of what? A vector, a sequence of numbers. Great job right there. I understand if this is tough right now, don't worry. 474 is probably like, this is a good refresher. 474 are for loops the easiest thing to do because we're going to just go through a vector of numbers right here. Now, when this loop runs, we're going to see that whatever I is, the first time it runs, it's going to become 1. The second time it runs, it's going to become 2. It's just going to increase this every time. And what do we get? Boom. Right there on the screen. And 474 needs this refresher because it's not the easiest things to write for loops. It takes a lot of practice, just understanding how to do it and doing it very slowly. What did Brian do first before he wrote his for loop? This is very important, and you'll see me do it tonight. What did Brian do first before writing his for loop? He wrote his what, and I made sure it worked. Before writing my for loop, I wrote my what, and then I tested it to make sure it worked. I wrote my skeleton. Great job, Muhammad, right there, and everyone's saying good refresher. 20 points. I wrote my skeleton. But you know what's even cooler? And 474 is going to get to see this. You know what's even cooler than cool? Put this inside of a function and say, we'll just put here I equals, and we don't want I equals. Let's say number equals 9. And 474 will get to do this when we get to functions. And let's call this times table. And guess what? If we run times table, guess what we get? We get a 9 times table. But if we go here and we put 5, we get a 5 times table. So now we've just incorporated, just for a second here, functions. And this is how quickly we can change things and write our own functions, our own for loops, and do all this if we know how to do the syntax. So let's do the first example here and practice writing it and see what we get. We could also, I want to do it. End, if we do end equals, let's say 100, and we go to end, we can put a second argument right here and make it go to 100, or we could just do, because Tolliver's it's gonna not be good for him. We could just have it end at 4 right here. So we're building our own functions. We're using for loops. All these great things make coding easier. And now I could just have this times table function. You could say, Uncle Brian, what's a 3 times table? And tell me to 30. He'll ask crazy things. He'll be like, tell me to 300. I'll say, well, there's your 3 times table to 300. And all this is running the code right here in the for loop. You can see the for loop inside the function, and it's assigning the values right here with the function. If this scared you, we're slowing it down now and going back to the very beginning. And now we need to know the context. All that was built just so quickly. You're right, Kevin, 20 points right there. Just get the answers. It's like, here we go. So what do you think this is right here? This looks a lot like our what. We've got right here that X is going to have assigned to it the values of what. This code right here looks a lot like what? This code right here looks a lot like what? I mean, it kind of looks like it's almost the what. Oh, thank you so much. This code looks like it might be our what for our for loop. What does it look like? Looks like it might be what? It might be the skeleton. So how about we go here to start and just make X a blank vector. Now X just exists as a blank vector, nothing inside of it. So now that we have what could be a skeleton, we maybe want to write to the first thing of X. How could we write to the first element of X? So this is just very slow right here. So just, this will help 320, I think, especially. How do we write to the first element of X? How do we write to that first element of X? We want to write to the first element of X. Let's just write only to the first element. How do we write only to the first element? Great job, Charlie, right there. You're right for another 20 points. Charlie's right. It's got some square brackets 1 right there. Great job, Charlie. Square brackets 1 right there. And then when we run this, we're just going to store this. Now let's see what it did. Okay. I like that. Whoops, I didn't want to do that. How about we go right here and do this? And, oh, wait. Okay. 5, 10, 17. It looks to me like only a few things are changing in this because I'm going through the vector of values and storing new positions and I'm checking. But notice right here, the code remains the same, right? Do you see what is changing in the code? So now we've written our skeleton. Let's type. How much am I going to type? Type it for me like you're here right now. I say, here's the keyboard. There you go, purple keyboard. Go type it. What are you going to type to start this out? Start me out right here. I'm going to start making my for loop right here. So what are you going to do? Don't type too much. FOR, Charlie's right. We're just type FOR. We're going to pause. We're going to get that snippet, and here we go. We're going to drop the skeleton inside of here because we've created a code that repeats. A skeleton is going to be a code that repeats, but right now this isn't a skeleton because it doesn't have a what that needs to change. We need to figure out our what now. Let's figure out our what first. We need to find our what, and great job right there, Kevin, saying hit enter after that. Great job, Kevin. We need to assign our what now. It's the same process we've been doing. Our variable, Ian, great job, Ian, 20 points right there. Ian saying the variable. We need to assign the variable right there. So the variable, doesn't matter what you call it. Anything. Now, what needs to change right here? Look at the code the way I was writing it and think about what needs to change. As we go through here and our code runs, what needs to change? Lucy, great job right there. Lucy, another 20 points. Everyone's following along really well. Lucy put this right here, and then there's one other thing that needs to change. So now, let's run this. And, oh, because I didn't put the vector. There's 2 things that need to change. There's additional spot that needs to change. Do you see here how this changes every time? So that needs to change. And then I'll give you a hint at what the vector is. Oop, 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 oop. Here's a hint at what the vector is. Number will be a sequence that goes from what to what. Number will be a sequence that goes from what to what. Number will be a sequence from what to what. You could do it as sequence. You could do SEQ. 1 to 9, boom. And you could do, like, it'd be the same if you go 1, 9. I prefer, since we're just writing a quick sequence, to go 1 to 9, if I knew how to write. And this should do it right here, and we've done it. How are people feeling? Pretty good. That's an easy example right there. If you're like, that was tough, don't worry, we'll be covering this in class. You pretty much just got a basic for loop lecture right here. Great job, Lucy. Another way to write sequence right there. That was a basic for loop lecture. Let's do some bigger examples right here. There's the walkthrough on how to do it, and we just kind of did it. Here we are with another basic for loop. The infinite sequence, 1 plus 1/2 plus 1/4 plus 1/8, all of this right here can be done, and we can do it rather quickly by doing, and this is 2, 4, 8, 16, so it'd be 1 plus 1 over 2, and then if you notice, this is going to change every time. So let's go here. This could be raised to the vector 1 through 100. And I think, oh, that's not good. This needs to evaluate. What do we got? Oh, it just gets so small, right? Oh, it does, the decimals. So options. It does get. Can't remember how to do it today. I did it earlier. But it just gets so small, and we could take the sum of this. So it's a good guesstimate of what we're doing. This is without a for loop. It's not going to be much better with a for loop. Oh, really? It's 1? No way. Oh, because it's... Oh, no, we're doing 1 plus. No, 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 no. It should be... That's not what we want. It should be 1/2. My brain is not working. 1/2. And then this needs to be raised to... Did anyone notice it besides me? Is the R file you are in for 320? That is correct. If you want, I can send it to you. Little bits right there. People, great advice right there. I feel like that explanation that you said, awesome so much. How do you highlight a code and put it into the... You can always just highlight it. Like if I write right here a vector of 1 through 100. If I write a vector of 1 through 100, you can then highlight it and do Shift 9. And then once you do that, it puts the parentheses around it. And that is what I want. And I want 1 plus that. And something's weird. Oh, it's doing that. I know what it's doing. We don't want that. So there's that sequence right there, which gets very small very quickly. I want the sum of this sequence. Well, that's 1 plus 1. That's 2.
Wow.
Cool. Geometric sequences, right? How about we do this with a for loop instead? With a for loop instead, let's go here and write this out. Now, this one right here is actually 1 divided by 1. Now, a little bit confusing, but if we were to write this as 1/2, how could we get 1 over 1? Be very careful. How could we get 1 over 1 right here? Be very careful. It's a little tricky. What could you do to 2 to get 1 over 1? What could you do to 2 to get 1 over 1? You could subtract 1, but don't do that. Don't subtract 1. What could you get to 2 to get 1 over 1? Think about kind of what we did over here, because I could have also done that. What can you do to 2 to get 1 over 1? We're trying to figure out how to write this skeleton right now. We can times this whole thing by 2. I agree. But only focus in on this 2 and be like, well, how could we get 1 over 1? We could subtract 1, but I don't know about that. I'll give you a hint. Raise 2 to the 0. And 2 to the 0 is 1. And this is 1 over 1. Now, when we do this, we get this. And what was that? Take a look. Can I make it so it all appears? Now you're seeing right here the 1/2, the 1/4, the 1/8, all of this right here. Does that make sense? We are now making this sequence of numbers, and it looks to me like just maybe, we built our what? Just maybe we probably just built our what? Is this making sense right here? So if you raise this, you get 1, and you're getting the numbers up there up top. You're getting these numbers right here. We built our skeleton. And do you see where the variable goes? Do you see where the variable goes? Is it making sense where the variable goes? So with this right here, a pattern is forming. So we're getting that skeleton, that code that repeats. It's actually up here also. So right here, this is our skeleton. But we need to put in a placeholder. So the placeholder is going to be right here because this changes. And that's the variable that changes. And then we can just make it go through the values of what through what. We need to go through the first 50 values, which I guess technically... So the first 50 values. Now this one, I would not count off if you did this, but we want to go through... That'd be technical. Be careful. Soraya, that's going to be... Or Coop, sorry, Coop. Coop, that's going to be... There's going to be an issue with this one. That's going to be 1, I believe. Oh, we need to do the sum of it. Well, this is going to be interesting. Because now it's just solving this each time. Oof, that's going to be a lot of fun. I wish. Let's go here to x save into, put a blank space for it. This is just creating x. And then we're going to go right here, and we're going to store into x. Let me start x at 0, rather. We're going to store into x what was x plus this. Does that make sense right here? No, you're fine, Coop. You're fine, Coop. Does this make sense that I am storing into x0, and then I am taking what was in x, adding it to this, and overwriting x? So this is just creating like a running total. This creates a blank space or a 0 for x to exist because x is at 0 right now. And then every time I run this code, it's going to add this to x and overwrite x. Does that make sense what's going on inside of my skeleton? It's just going to increase the value by this. Take what x is, add this, overwrite x. Then it's going to move I to the next value, and then it's going to find the value of this, add this to x, and overwrite x. So every time we do this, x is always increasing by whatever that is, and just overwriting the value of x. Then we increase x by whatever it is, and overwrite the value of x. So now let's take a look right here. There's one issue with this. When we observe x afterwards, it's 1. Because, right there, Coop points it out, we want to start at 0, because 0 is when we have this right here, and that's when we start at 0. You are 100% right, Coop. 50 points right there. Great job, Coop. You are right. We need to start this vector at 0. And then, technically, we need to go through 49 if we're doing the first 50 elements. So, I wouldn't really count off if someone did 50. I don't know. I don't think that'd be points counting off. How do people feel of their understanding of this one? 1 to 10, like 10 means you get it 100%. 1 means you have no idea what the heck we're doing. Give me some feedback. I know these are tricky. How do you feel about this right here with the way I wrote this or your understanding? 10 means like, psh, I got this. That's easy. 1 means like, I have no idea what the heck you're doing. Like I am completely and utterly lost. We got a 7. 6.5, 6.7, I'll take that. 6 is good. As long as we're towards the middle, I feel pretty good. We're going to do more examples, more coding practice right here. We're going to probably go for another like 45 minutes. It's just doing these, trying them out for yourself, writing the code, getting the format. When I do this, it just puts it in the global environment. Then print it afterwards. It'll store X in the global environment, and then you can just print X afterwards. Great. Avery right there, 20 points. It'll store to the global environment, and then you can print it afterwards. So... when did you put the X save into 0 above for the loop? Why did I? Oh, because if you don't have an X and you try to write into X, so I'm removing X, it'll tell you there's no X. So I just removed out X here. That stands for remove out X. And that's our little X from earlier. That's not the big X we're using. So many X's. And I removed it. So now that there is no X, if you run this, there's no object X to store into. So I like to, a lot of times, if I'm doing mathematical computations and it's adding things like we're going to see how much this plus this plus this plus this is, then I would start x at 0 right here, or you could use a per length vector. For the loop to paste, the answer we have to have paste right. You can use cat, paste, or print. All of them have slightly different features on how they work, on whether you can capture the output. I prefer the combo of cat paste. When you do cat paste, it prints to the screen. You can't capture it. You see how it doesn't have a vector or a position next to this? That the cat literally makes it show up. If I were to only use paste, which you could do, it'll have, I believe, the vector position on it. So this is now the string, but this is literally just showing it to the screen. It's the way I like to do those right there. What is the other parentheses for? Which thing, Nathan? Thank you so much, Nathan, for asking. Which other parentheses? Is it on this one up here? I'm slowing down for all the questions. No, please ask questions. Lucy, yep, starts at 0. Is that why the loop you just did not paste the answers though, right? Yes, why I wasn't showing them. Yep. We could maybe put that inside of a... You know what we could do? We could put here cat x, and then we could see the running total as it runs. If you notice right here, oof, look at that. It looks crazy. Oh, my options digits is going crazy. It's option digits. Wow. All I have to do is just talk about it, and I'll slowly remember the answers. So it's option digits. We're going to put the option digits to 5, and now it's going to print it to the screen. It also makes it look all messy because... Ooh, why is that one looking all like that? 1.99999. So what we'd probably want is the cat paste. And this is why I use the \n to start the new line. Cat paste, \n, and now it should... It says we have a parentheses error. Nope, we don't. So now you can see it right here, the numbers working. That's pretty cool right there. So the sum should equal 2. That is correct. It's a geometric sequence. Please, math majors, tell me if I'm wrong. But you can see the running sum right here as you do it, which is kind of a neat feature. But does that make sense what we added onto this loop? We didn't have to add it, but I made it so every time this loop runs, it'll show me what is currently in X. It goes to X, and it just prints it to the screen. Once again, if you notice the difference before we did the cat paste right here, it wasn't doing a new line every time. So with this right here, we get the new line, and I noticed all those 2s are actually where it gets rounded to 2. So it looks all messy right here without the cat paste. I like the cat paste because you can then make it do a new line, and you could check the running total to see it eventually kind of converges in on 2. It's like a limit, it'll approach 2. Just like print, enter, X. Yep. Basically, you could use print also. I like the features of the paste function. So the paste function has this sort of format, and then I like the cat because it doesn't put it as elements of vectors. It just puts it out on the screen. So it's just preference. Once again, there's about 1,000 ways to code everything, or 10 billion ways. You might still be underestimating it. Lucy had a question about, was Lucy's question again? When you type the name of a vector, doesn't it automatically print the elements in a vector? 100%. Yep. If you ever see something that says print X, you can just do this right here. This right here, print X, is the same as print X. Sorry about that. Coop, 100 points. Coop, thank you for pointing that out. Print X and X are going to do the same thing. Really good practice. Really good practice. Great time to ask all those questions. Thank you, Coop, earning everyone 100 points right there. Excellent job. And this is just a walkthrough of it. For loop over categories. Different thing right here. Although this task is more easily accomplished by running, thank you, Lucy, the aggregate is a really great function which will aggregate y by x. It'll do it over a different function. And let's take a look at this. This is a really powerful function when you take a look at what I can do. Oh, it's already there. So right here, we're loading in the reg class. If you do not have reg class, please go to install.packages, quote reg class. Packages are basically like installing a video game. After you install the video games, oh, dude, it's it's Wacky Wednesdays. Crash, take it away. So after you install the video game, you can then play the video game. And so we go right here and we load the library. Loading the library is going to give us access to the tips data frame. And in the tips data frame right here, we can see certain variables, like what day of the week was it. We only have like Thursday, Friday, Saturday in here. And we can go to the tip percentage people had and the weekday it was, and we can get the mean for each of these days. You know what you can do really easy? Median, standard deviation. All of these things right here can be done very, very quickly and very easily. You could even change the variable you want to say, well, what was the standard deviation of bills for these days? All very quickly, very easily. You could get, I think if you do summary, we should be able to get, let's see if it runs. There is a summary for each day. So if you want the 5-number summary of something like the bill for each day, like basically doing a subset for each day, rather than doing a subset, you can just aggregate by a certain variable, y tilde x comma data equals exactly. So this is the formula format here. It's the y variable, the x variable, data equals data frame, and this is function name. So if you're looking at this right here, it's y tilde x, the y variable, the x variable, next argument, that's the formula argument. The next argument is what data are you working with? And then the final argument is the fun equals the function you are going to use. So in practice right here, the one I just did was I want to look at all the bills aggregated by weekday, which basically does a subset. Then we're doing this from the tips data frame, which tells it where these vectors are located. And then the function I'm running here is summary. So rather than doing a subset for each day, well, there you go. There is a subset. You know what's even better? Store this as a data frame right here, and guess what? You can then sort it. Ooh, oof. Did not do the full summary? Oh, that was unexpected. Really? Wow.
Wow.
We'll do mean. We'll have to look at why that didn't do it, but it didn't get me all of them. That's interesting. I'll have to come back and look at that. The way it's storing that is not the way I wanted it to. Go back and look at that later. So with this right here, we are going to replicate what this function is doing. Let's bring it back to its original form right here. We're going to replicate. Can you put the mean extra in the fun to see what the means for each weekday for each variable? Can you put them? You can do multiple variables. I've never gotten aggregate to work for like mean, standard deviation, like multiple things. And you could do that. I don't use the $sign. I usually call the data. Charlie, you are correct. Coop, try the code and send it to me. You're saying after summary, could you put the mean? So if we run summary right here, we get the summary. And let me just store this into object X. Object X does have everything in it. Object X is 2-dimensional. That's good. Object X is weird right here, though. The second dimension has... Oh, it's a list, isn't it? Let me look at what Object X is. Is it a list? No, it's a data frame. But the data frame has in it... The way it's displaying there is not right. Because row 2... Yeah. I don't like the way this is storing right now. It's rather interesting. This is all one named vector. So I'd have to look at this more and see what it's dealing with exactly. I've never done it with the summary. Fun equals... So you'd have to put that in here as a vector, and I don't think it'll work. Let's try this out real quick, then we'll do the for loop part of this. I've tried things like this before. It could work. You never know. So function... and you'd have to separate them out. So you'd have to put in... I haven't gotten it to work with two... Let's take 10 seconds here. Let me see right here. Aggregate with 2 functions in R. Oh, they're using apply for it. Let me look at the solution someone gave. Okay, wait, here we go. Oh, they're creating a custom function. Okay, so this is quite the workaround for it. So they've got aggregate, all the variables. So we'll just take our formula right here. And they've got their data frame called X. I'm literally on Stack Overflow. I've mentioned this during class. Like Stack Overflow is like the #1 way to learn anything. And if you type a question, you'll usually find it. So they're creating their own custom function, which concatenates these two things right here. So there we go right there. We've got the mean tip percentage and the sample size. So if you wanted a list of stuff right here, here's the name. You could call this mean, and it's going to say tip percentage mean. I don't think that'll get mad at us. And then you want the mean of X. It's going to treat X on whatever we're doing, and that takes the mean. And you could also take the median, and we'll call that right here median. We'll capitalize these right here. But now we have it that we can take the mean and the median. So a little more complicated. You have to write a custom function. I can't find the code to download Red Class. Let me put this in the chat right here. Thank you so much, Avery, for asking that right here. So that's the code for downloading Red Class right here. And this was pretty complicated right here. This was creating a custom function to, let me put the function argument on a new line. This was creating a custom function to do multiple aggregates. So it's still just running one function, but the function is a function that concatenates the mean of whatever we're doing, and it's taking whatever data we give it and finding the mean of it. So a little bit complicated right there. That's a good one. I can see what it's doing. If you ask me to write that, that might take me a little longer than Googling and finding on Stack Overflow. Yep, restart R, just hit restart, and then if I ask you again, maybe don't restart. Custom function to do multiple functions, saving that here for myself. Custom function to run multiple functions is the way to go. And that's really cool right here, so we can get an aggregate with multiple things on it. Thank you, Stack Overflow. So how about we do the same thing we have right here with a for loop? Now, I want us to think about how we do this. This is a good review for 320 assignment. The first thing we want to do right here is take a subset. So let's talk about taking a subset. If I want to go to the tips data frame, and you can see right here the tips data frame, how do I start by taking a subset on this? Jessica, great question. Let's first find just a weekday. No, Jessica, great question. 20 points, Jessica. Let's just find a weekday. Charlie asked a question about, that means that repeat the question, Charlie. Might have missed it. Oh, is Bill $ weekday the same day as Bill tilde? I would use the formula format. It's not the same thing as Bill tilde weekday. No, it's not the same thing. Great question right there, Charlie. It's not the same thing. Tips is not found. Make sure you do this. You do data tips. Once you've got it loaded up, make sure to run data tips. Great questions right there. Make sure you have data tips loaded up. Thank you everyone for following along right here. So how are we going to start by writing a subset to find a certain weekday? How are we going to find a subset for a certain weekday? I think we might go 2 hours tonight. This is good coding practice. It creates a formula. So it assigns one to be y in a formula and assigns the other to be x in the formula. So it says this is the y variable. It's one argument. And it basically says this is the y variable and this is the x variable. And these come from the tips data frame. So we could do tips $weekday. Lots of ways to do this. Oh, wait. Oh, it's tips. I was like, where's my stuff? But how about we do this? That's it. We could do it that way. There's ways to do it that way. How about we do the following? Now all I need is a what? Now all I need is a what? Do you mind copy pasting the x function? Yeah, here we go. This right here. Oh, you don't want that one. That one is not going to work. This one does work. It says now fun mode was not found. Don't worry about these up here. Don't worry about these up here. This was practice. Don't worry about those up top. Don't worry about those up top. Kiana, good to see you there. Oh, awesome. Good to see you, Kiana. Don't worry about those up top. These up top were just practice right here. What do we need inside of here? So what do we need inside of here right here? We've got sub, save into. Let's see if it runs. That runs, but what do we need to take a certain day? We need what's now. What do we need to take a certain day? Lucy, great job. Great review. No, thank you. Thank you, Lucy. What do we need to take a certain day? We need what's now. When we're subsetting right here. We need what's now. To get a certain day, we need what's now. When we do subset, to get a certain day with subsets, we need what now? So when we use we'll think about subset first takes conditions. Yes, we're going to take the tips data frame and then we need certain conditions. So let's say weekday equals Friday. Now let's look at our subset and we should only see what? We should only see Friday. How about this? Weekday equals Thursday. Look at your subset and what do you see? Only Thursday. Does this make sense? And the weekday will be a variable, so it won't be in quotes, but the name of the weekday will be, because we're going to say weekday is logically equal to Thursday, and this will create the subset. If we change this to Saturday, watch the subset here, it will change how much we have inside of it, because now only Saturday is taken. And notice that We're just changing one thing to change the weekday. How about we go to the sub now, and we get, I think we're getting tip percentage, right? It was tip percentage. So tip percentage for the subset, and we take the mean of it. And what do we have? I just found the mean of what? I just found the mean of what? Just think about what I found. I took a subset, weekday equals Saturday. Then I went to the mean for the subset, tip percentage for Saturday. The mean of Saturday tips. Yep, you got it. And I mean, from here, let's think about this. Well, how about we do this average tip percentage right here. And let's go right here and store this into Saturday. And let's do this. Well, there we go. How about we go and do this right here? Wait a minute. This is starting to look like I have a what right here. Like when I change this, I'm just changing one thing, and it's starting to look like Brian's created a what again. Because I'm actually solving the answer right here by doing this. It's starting to look like this is our what now. It's lots of practice, lots of practice. You should be like, oh, you just built a what? It looks like a skeleton right there. That's a skeleton. Skelly right there. Skelly, 20 points in the chat. You got it. That's a skeleton right there. Boom. Let's take that. Let's write out that FOR. Let's put that for loop. Boom. You got your skeleton inside there. I'm going to highlight the code and go to insert, reindent lines, fix up those lines. Good. So now you got to be careful though. Here's where we get tricked. Now, if you look at this, we're going to go right here. And what do you think we should call this? Let's go for something logical. Be very careful because you might overlap your names. What are we going to call the variable? It can be called anything. What are we going to call the variable? What are you going to call it? So the vector is what the variable will go through. So whatever we want this to change to will have to be the vector. Does that make sense, Charlie? Like the variable will be just a placeholder. It'll be any name. We could do AVG weekday. We could do, let's do this. Let's go, how about this? Day O week. Because that's the day of the week. Now be careful. We want to be careful by calling things weekday. The vector could be day. That would work. And we won't put it in quotes because it'll be like an object we store into. It'll be like when you assign to an object, it won't be in quotes. It'll just be like an object right here. So we have day O week. And then guess what? This becomes day a week, and this becomes day a week. Because remember how I was changing it each time I was running the code? That's what we want to change every time we run the code. And then now, vector right here needs to go through what? Just tell me, you can abbreviate them down to one letter. Vector needs to go through blank, 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 blank. And there's only 4 of them. Vector needs to go through, wait, the variable is the day. The vector is what it goes through. Variable is just the placeholder, and then vector is what it goes through each time it runs. So every time this runs, day of the week will become the next thing in vector. So the vector is the first time it runs, day of the week is this. Next time it runs, day of the week is this. Next time it runs, kind of, very close, Coop. You would be right. This one's a little bit different. You can see it over here. It has Friday, Saturday, Sunday. It'll be the days that are in here. So you're basically right. And how can we figure out what different levels there are to day of the week? How could we figure out what different levels there are to day of the week? Like if I wanted to look at the different options there are, how could we look at the different options for the levels of day of the week? So let's go here, look at the tips $ weekday. Oh, you got it. Yep. Let's just go to the levels vector on it. And guess what? This means the first time this code runs, it'll be Friday, then Saturday, then Sunday, then Thursday. Guess what? We have done it. I know that one was a bigger one. That one's like a larger one. That one's a medium one. How are people doing on that one? What questions are there? Just slowing down. That's not a weekday, though. Don't argue with the question. 100 points there, Coop. I agree. It's not a weekday, right? Oh my gosh, my things are changing around. How's that looking? Does that make sense that when this runs, it's going to take Friday, store that into day a week, run the skeleton. It's practice, Charlie. It's just practice. The next time it runs, it's going to take Saturday, store that into day a week, and run it. Next time it runs, it goes Sunday, stores that into day a week, and then runs it. Next time it runs, it takes Thursday, stores it into day a week, and runs it. And that's how we get the vector right here. It's just a lot of practice. This is, the more you practice, the better you get. You should have saw me my first semester doing this. Lots of mistakes, lots of mistakes. You're going to make mistakes. You cannot sit down the night before a coding test and be like, I'm going to learn how to code. Could you imagine if you had an interview? Refer back to your brain, exactly. If you had an interview with Microsoft or Google tomorrow, would you think, I'm just going to sit down and learn how to code? Because they say, we're going to hire you as a coder. And you say, I'll just learn it tonight. No, don't do that. If you said, I'm just going to learn how to code tonight, that would not be good. That's not going to happen. It'd be bad. Let's do another one right here. Here we go. Another one. For loops over categories. The data frame product in red class has information on a new product which is considered success. Outcomes are success and fail. And the product categories are anonymized with A, B, C, D. Write a for loop that produces a vector called prob failure, which contains the proportion of failures for each category. So we can actually just see the results right here, which is really awesome if we load the data first. So here's the data. This is what we should get. So this is the answer to the question. But what do you think we're going to do to only get product A's? What do you think we're going to do to only get product A's if we're going to do this as a for loop? What are we going to do to only get product A's? So we've got the product data set. And how could we only get product A's? How could I only get product A's? I only want to get product A's. I bet you this one we can do in 6-7 minutes. You'll be like, what? That was easy. It was the same thing. How can we only get product A's? You could do that. We could do it that way. We can do it that way. If no one says anything else, I'll do it that way. And I think it's going to be in quotes. Well, why not take a what? We could do it the other way. We could do it. Why not take a this? Hey, what's up, Mohammed? So good to see you. Oh, yeah, Mohammed. Yeah. Congratulations on graduating, Mohammed. Excellent work. Mohammed is correct, though. We could do this right here to see which ones are product A. And then we could find which ones are product A. And these are the rows. And then we could go here. And we could take only those rows and save this as a subset. Notice the subset has this amount. But we could do the same thing by going to subset of product. And in product, if I knew how to spell, we want category equals to A. Now, it should remain the same. And it does. No, don't confuse me. Oh, Ashley's here too. What's up, Ashley? Good to see you here, Ashley. Love it when people are swinging by. Good to see everybody. No, let's throw out some 50 points for all the visitors. Love it. Does everyone notice that these two codes do the same? I think the subset's a little bit easier, and there's a lot of ways to do this. But does everyone notice right here we have that we create a subset by going to the rows, finding products equal to category A, finding which rows are that, and taking from the products data frame only the rows that are that, and storing that into sub. Then right here, we have sub is a subset of the data frame product, and we have here that category is equal to A. So think about this. We only have product A's right now. So we're almost there. Don't worry. Wait, focus. You ready? We got this. Now we want to look at if something was a success, which is the outcome. Let's go here to sub outcome. And all I want to do is this. So now I just want to see if it is a success. Oh, no, Muhammad, no. So we can subsets replace. You can use the which can be used to subset. I'm gonna do it this way right here. Either one of these both codes are the same right here. So now I just want to see if it was a success. So how could I check to see if these are successes? How can I check to see if this is a success? So I'm just looking at my subset, which is only product A's. It's all product A's. And then I want to see if it is a success. How could I see if it is a success? Think about a logical test to see if it is a success. Great job right there, Coop. Earning everyone another 50 points right there, Coop. Great job, Coop. You're 100% right. Yep, we're just seeing if it is a success. Well, now if I want to find the percent, just do what? Muhammad, great job too. Another 20 points, Muhammad. We're just giving out all these crazy points, I promise. Because we just got some points. I'll give out more, don't worry. How could I then find out the percent of successes? And this is what Muhammad was noticing earlier, is that I did this and did it like really quickly by just wrapping it. Not percent in percent. We want to find out the percent of successes. Percent and percent will be contained in. That'll be how many. Ian, you're so close. Ian, another 20 points. Ian, you're so close. Ian said some, which is very close. That's how many successes. I think we're actually doing failures. Ian is right that is how many successes, but you're so close. You're so close right there. Ian, you're so close. Not which will be which ones were a success. So that'll tell us the positions of the successes. How could I find out the percent of successes? And I'm pretty sure we're actually doing failures. We're actually doing failures. We're going to change over here to failures. Mean. Great job, Charlie, right there. That's the mean. Let's look at our check on this to make sure we got it. That is looking like we have the same answer. Wait a minute. How about I just change this to B? Ooh. How about I just change this to C? Brian, it's looking a lot like you just wrote your what? You know it. 20 points in the chat. Brian, you're just changing one thing right there. It's looking like you wrote. Let's just call this answer. Store into answer. Blank vector to create a spot for it. Answer for A. We're on D right now. We'll put A in here. And let's go here. A. Oh. Didn't put my save into. And people are saying it. You wrote the skeleton. Exactly. We wrote the skeleton right here. So now we have the spot for the answer. We subset, and then we store into that spot. And we notice here that A has the answer stored into it. All we have to do is change this. We're going to take all of this right here and just drop it right inside a for loop. There's the for loop right here. And let's go to code, reindent lines. This just makes it look pretty. Reformat. And so now the variable, let's just call this category, cat, gory. Don't want to name it the same thing as something else. You know what you could do if you're really nice? You could go right here and just do a vector of A, B, C, D. I think that makes it easier to see what's going on. If you look at this right here, the first time this runs, yes, Coop. That's why I love doing multiple examples. Coop, 20 points right there. So if you notice right here, the first time this runs, it's going to store A into category, run the code. So literally category gets assigned to A. And just notice, the next time it runs, it stores B into category, and then it runs all the code right here. So it's all about just writing that skeleton. Like I said earlier, you're going to see me writing skeletons. Good job right there, Coop. You can't, first time hearing this, I fear a few people got discouraged. I'm not going to look how many people are viewing the stream right now. Don't tell me. I should. It's probably on the screen somewhere. I shouldn't look. Let's try another one right here. These are just the instructions on how to do it. So if you ever want to do it yourself, write a for loop that goes through the length of empty cars and adds together the miles per gallons. Start by creating a place to store values into a vector. Oh, cool. How are we going to start by creating a place to store vectors into a value? You got this. We got this one. This is like a little bit easier now. Who can help me out by creating a place to store vectors into a value? Who can help me out by creating just a place to store vectors into a value, like store it into a vector? Who's got that? Let's throw another 20 points. Everyone following along. How can I just create a blank spot? Oh, you're welcome, Coop. I just want to create a blank vector. I like to set my vectors to 0 if I'm going to be adding things. So how are we going to do that? How can we just create a vector that is assigned 0? Who's got that in the chat? Just create a vector that's assigned to the value of 0. The more you hear it and the more it just sounds like you're just talking to someone, like, create a vector that has 0 assigned to it. Try that. Try to just get that. Create a vector that has 0 assigned to it. That's our first goal. I know you got this. I know you got this. Create a vector that has 0 assigned to it. Like some vector name, save into 0. Like 0, save into some vector name. Who's got that in the chat right here? So we're just going to create 0 in a vector. Just be like, this is 0. Wait, we don't actually need all this stuff up here. 20 points online. Some name vector. That's worth some 50 points right there. I like that. Some name vector 0. Ian, thank you so much right there. Ian, that's awesome. I like that. Some vector name. Verbatim what I said. Perfect answer right there, Ian. Great job. So we have right here, we need to then take, we're going to add up miles per gallon. So let's go to MT cars, which is a data set inside of R. And we're going to go to the miles per gallon. And we should probably start at the what observation. Like, maybe start at the what observation. If we're going to add things together time and time again through this, we should probably start at the what observation. What do you think would be good to start at? We should probably start at the what observation. You know, we probably need to be adding this to, let's add this to some vector. And we probably need, if we're doing just the first, because if we're going to do this for each one, like, add and then add the next one and then add the next one algorithmically, then what should we start at? What position in MT cars for miles per gallon vector? Because this is just a vector right here, and we should start at the very beginning. That's such a great question, Nathan. It's basically a basic for loop practice. Nathan, 50 points right there. The answer is, well, why wouldn't you just run sum around it? And that is the right answer. You would just run sum. This is just some practice right here on how to write a for loop. But the answer is you should probably just write sum around it. So right here, how would we do this right here? How would we go to the first element? Nathan is very correct, though. You should just use sum. This is just practice, though, on the kind of syntax of a for loop to see how it works. So we have here some name vector has nothing in it. Now we're going to take some name vector, add probably the first element of this. Great job right there, Ian. There we go. And now some name vector has increased by 21. But how about we do it again? And we do it again. As we go through here, what do you notice? The only thing that is changing is what we're adding to it each time. So it looks like we just created, say it in the chat with me as I do this, it looks like we just created a what? That looks to be the skeleton. The skeleton is the part of the code that has the repeating pattern. And this thing that is changing needs to be replaced as our what? This thing that is changing needs to be replaced with our what? Important, you can see this is a simpler one. This is like a level 3 one. This thing that is changing needs to be replaced with the what? So that thing that changes every time we run the code, that has to have a what in its place. Variable right there. Ian, great job. 20 points again. That's going to be replaced with the variable. And so let's go here to variable and just call this position. Sure. I call POS for position. You could do I. A lot of times people use I for really short, like the ith element. Now, this is where it gets a little bit confusing. We're obviously starting at what? Like, we're obviously going to go through the first element. But then the question becomes, we should probably do all of them. So we're going to go 1 through the what of MT cars MPG. So we're going to go through all of them. So we probably need to go through the what of this. So we're going to go 1 through the what of MT cars MPG. Because we want to do each one of them. We want to do like the first one through all the way through the last one. So that's the what of the vector. And we want this code right here because I've got all the practice code around it. And then we'll print it. And then we'll do a logical check of it. And we want to go 1 through the what of it. Not quite the variable. Great job. Good test right there, Avery. We want to go 1 through the Basically the end of it. I don't think end will work. I don't know if end is a function. Oh. It's a time function, so we don't want end. 1 through the length. So length tells you how long it is, and 1 through the length will give you all the positions. Because the length of this is 32, so we created a vector. Does this code here make sense? 1 colon length. The length is 32. So all this code right here is it's finding the length for us. So it's doing 1 through 32. So just look at this right here. Length of the vector is how many elements are in that vector. So when you change it right here, it is 32, like it literally is. So we're just putting the length of the vector because it's going to tell that to us rather than us trying to type it in and maybe making a typo, or maybe someone changes the data set and the vector length changes. So this will then look at the vector and say the vector is this long, go for this many elements, because maybe a year down the road, the data set's bigger, so we don't want to hard code in a number. And when we run this, we get the same answer. This was an easier one. I want to point out Nathan was very, 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 very correct. We would not do this this way usually. We would just sum it up. Like there's no real good reason to do this. I think we can do we do the crack one in here? It is a fun one. I think this is the one we just did right here. Oh, question number 6. A few more questions. Let's do this. Basic for loops. The function f defined by the following chunk takes an argument, a single value vector, and returns. My vector isn't found for some reason. Nathan, which one are you doing? Let's hop back a little bit. Did you store the sum vector name, Nathan? Can you show me the error message you're getting? Did you store some vector name? And thank you, Nathan, Avery, Ian, everyone, Lucy, everyone. I know some people might have left. It's a lot. You've probably been coding all day, been practicing all day. Internet's been a little bit crazy. I appreciate it. It's a lot of work, and it really comes down just to practice. Good job, Nathan, right there. Let me know which issue you're running into. It really comes down to, it's just practice. It's every amazing instrument person you've ever heard. That's what we call them, instrument persons. Here, I'm going to take your code, Nathan, and check it out. Every instrument person has put in lots of practice to become an amazing instrument person. Okay, 0, that's it. The lines don't work. This code right here will be, we won't run this code anymore because that's got the placeholder. I love that it destroys the syntax. This right here needs to end. Losing our minds one step at a time. Oh, this won't run right here. This probably will run. Yeah, this up here won't run, and that's okay. So the top one right here doesn't need to run because P, at least right now, P is not stored. But when you run this down below, it will run. So it should run right there. The for loop will run because it'll assign P. For loop will create P, but you can't run it beforehand. Like if I try to assign this to like Q or something like that and then run it. What's up, Daniel? So good to see you. No, we're probably going to stay for another like 35 minutes and do a few more examples. Check it out. We've been doing a lot today, and I think it's been really good practice. This is a tougher one, hence why we're doing the coding nights. Want to put a lot of practice, and this is like just dedicated to these topics right here. So, Daniel, get ready. Is it working for you right there, Nathan? Just try running only the for loop. You don't want to run like this right here outside the for loop with the placeholder. So what is the code I run? The for loop right here will create it. So when you run this right here, it actually goes through and runs this a bunch of times. So you can see right here, this loop is going to run right here and create, store into some name vector into it, the sum of some name vector plus empty cars, the sum of this right here, and it's going to loop over. So does that make sense, Nathan, right there? It's going to repeat that for the length, 1 through the length of empty cars MPG. Let's see. This one looks fun. We have right here that f, the function f defined, still not working. You might need to send me your file, and I'll have to take a look later. Send me your file, and I'll take a look, Nathan. I'll take a look, and I'll feel what's going on. You'll stay after? Okay, cool. I'll probably hop on Discord or something after this. So the function f defined in the following R chunk takes an argument x, a single value of the vector of values, and returns the value of x raised to blah, 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 blah. Imagine that the value of f gives the cost of some manufacturing process when the value of some decision variable equals x. It is desired to minimize the cost and thus find the value of x that gives the smallest possible value, blah, blah, blah. The choices we have for x are the variables sequence the length of 474 that start from 0 and ends at 1s. Initialize a vector called cost and write a for loop to determine the ith element of cost as the value of f at the ith possible value. Oh my gosh. Define a vector called possible x. This is a sequence from 0 to 1 that is a total of 474 elements. Cool. Let's do that right here. So we have right here, possible x is a sequence from 0 to 1 of length 474. And so now we can check it, and it looks like we have created it. It has 474 elements, and we have created our possible x. Initialize a vector called cost that is empty. Show me how to do that. Help me out here. How do we initialize a vector of cost that is empty, which is where we're going to store this? How do we initialize a vector of cost that is empty? Now it says empty, it doesn't say 0. Would 6429 be the... You got it. Great job right there, Rachel. 20 points, Rachel. You are very correct. That is it. Great job, Rachel. How do we initialize a blank cost vector? Yes, great job right there, Ian. Excellent work. Boom. Take the looping vector to be integers from sequence 1 through the possible... Okay, we got that. So here's the looping vector. So it's telling us what the vector is. Remember this from earlier. So it says the looping vector is going to be 1 through the length of this. Let's check to make sure this works. Cool. The positions of the elements. Choose a name for the looping variable. Awesome name. Choose a name for the looping variable, then get your code working for the elements in the position 144. The value of this and the function evaluated x, it turns out to be this. However, make sure you do not hardcode 144, but rather use the name of your looping variable instead. Write your for loop once this works. Okay, cool. So it wants us to use this function up here. Haven't done this one in a while. And we go right here. It's the possible values of x right here. And let's take the function and go right here and grab this. And we're going to store into this. Let's take a look. Brain is slowing down. Just going to take a look. Whoa, 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 whoa. Oh, no, it's position 144. Position 144 in possible values of x. There we go. There we go. We're getting it. It says wrong on the quiz. Which thing does it say wrong? It's the sum of it, is it? Let me double check that answer. 2 seconds. We're going to double check an answer right here. All right, let me go grab this. Let's double check an answer right here. Very important one, right? Let me go look. Quizzes. It might have more decimals or something. Hey. Here we go. I see it. Ooh. Oh, I see what it is. I see what it is. It's not. It's the HP though. Rachel, does yours say HP or does it say something else? So the questions might be a little bit different. Maybe a little hint right here. I think yours might say HP. Yours might say HP. Well, that's not right. Let me look at what's going on right here. Some vector. Let me go look at horsepower. Two seconds. It asks for both, for MPG and HP. Yeah, I think that's an error right here. Because, yes, use a for loop to find the sum of the HP. Let me change this one. Not that this is the answer. And then we look at the other one. Okay, that should be fixed. Update. Whoa, 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 whoa. Did it just change that on me? Oh, no, put a comma. Okay, that's fine. And then The sum of MPG cars. Okay, here we go. That's weird. Well, I'll be. What happened here? Okay, not that these are answers. Not that those are answers right there. Okay. Give it. Tell me if there's an issue with it. Quizzes. I'll make sure this has enough attempts. For loops. Edit. 3 attempts are allowed. Please tell me if you have any issues with the attempts. It should be saved. It should be good. It asks for both. Is it working now? Please tell me if you think you got it wrong, you got it right. Let me know. I made some changes to it. I don't know why those were wrong, but I was just checking the answers right there. But it should be this, and you can actually kind of check it by going to sum empty cars and going to, I think one of them is HP and the other is MPG. It should be. Nathan, if you got it wrong, just message me and I'll fix it. It should be, if you put that down, you're good. You're right there. But now it asks me for both. The questions will change. There are some questions that cycles through. Please tell me if you see any other errors or any other small things and we can get them fixed up. But sorry about that there, everybody. Sometimes there's an error every once in a while. You never know. So with this right here, we'll take a look at the remainder of this question. We'll do a few more right here. Is it working now, Rachel? Rachel, message me if you want, even if I'm not your teacher or anything. If it had a problem, I can fix it. So if it's like, hey, Brian, I'm pretty sure you said this was the answer and I put this in and it got it wrong, I can just fix it. So I can fix up any sort of quiz thing. But so is everyone good on that? If you put in the right answer and it told you you're wrong, I will go in and fix it for you there. Be like, hey, Brian, you said this was the answer. You got to fix it now. How are we doing, everybody? Let's throw out some 50 points right here. 50 points. Sorry about the errors. It's the Wi-Fi. It's the campus Wi-Fi. I'm blaming the campus Wi-Fi. I'm kidding. So with that, let's take a look at the end of this for loop right here. Because what are we doing? We're going to loop through all possible values of this and try to minimize the cost function. And it's been walking us through how to do this because right now, we've been taking and running this for the possible values of x. But what we want to do right here is just use all these possible values right here. And when we do this, this will become the value we're using. So we have right here, this is what we're changing. So let's put this right here. And this will become the value of x. So let's store this into x to begin with. Probably a better way. That should do it though. I could just put awesome name. And there's that. Because this is my skeleton right here. The skeleton that we wrote just a moment ago is going to take an awesome name and is going to become the values of 1 through the length of this. It's going to grab my possible values of x and take the first element, store that as x, and run this. Now the cost is our current blank vector. I like to write it all at once. And with the cost being the current blank vector, it's just a spot for us to store it. And let's store into position. First time we run it, position 1. And this should do it right here where we run this. And we should get the results when we look at the cost vector. There we go. And if we find the minimum, which we can do pretty quickly, was it really just going to be the last one? Well, that's not that fun. So if we go right here to the minimum of the cost, or which.min, I think it's going to be 474, which is a rather bummer. Oh, which.min. What are people thinking? What questions do people have? We've done a lot of questions tonight. Might do 1 or 2 more right here, but that finds the minimum cost. Find the position in which the cost is the minimum. And you can look at the optimization right here, all this good stuff going through, and we've done it. And we could plot the curve. So I think we have the ability to plot the curve right here. Figure too large for margins. And it should look about the same. Oh. Oh, wait a minute. Something went awry on our function. Let me take a look at what's going on right here, because we should be seeing the cost minimized here. I think something went wrong with what we wrote. Because this shows us that right here, if we're changing the possible values of x through the vector, These are the possible values of x. And we're storing them into x right here. And then we're solving this equation. And so with this right here, oh, look, no. It is, no, these are the values, possible values. And then the cost, we should see that dip at the early part. I guess it is dipping, right? So it kind of makes sense. Don't know if I could figure it. Yeah, thank you so much, Nathan, right there. It's pretty tricky. It is pretty tricky. This is a vector. Let's go here to the 1 through the length. We want the y is the cost. Oh my gosh. It's going to be reverse. Don't like how this one works. Well, this is not looking the exact same, which I do not like. I want to figure out why it's doing it. Can you go back up to the tips loop again at some point? Yeah, let's do that here in 2 seconds. I'm going to try to finish this one off because something is not working exactly right on this one. I don't like that. So right here, so x is going to become, there's something wrong about this one. We have right here, this becomes 1, and we want to go through the possible values of this. Wait a minute. Wait a minute. The possible values are what we're going through. So why am I going through 1 through the length of this when I can just go through the possible values? Now, awesome name is what we have right here. And we just want right here, we could put a placeholder. And awesome name is what's changing. And awesome name, let's just call this... let's call this Y, or wait a minute, we'll call that X. That makes life a lot easier. And then inside of here, I'm just going to put a quote and put quote X. Okay. Oof, that's bad. Oh, I am just losing my mind. As dot character. I'll go back up in a second. There we go. Now let's take a look. Okay, that's better. And is that the way the function looks down here? Because it goes back up towards 1. Okay, good. And now let's look at the way this looks because we've now created the cost. And let's go here to plot what we've created of the possible x, which I hate this is in reverse, with the cost. And it's still looking like that? Let me look at the equation down here. Function from 0 to 1. Because it should be taking, I think it's taking the wrong values right here. It should just be plugging in those values. Neither empty cars question is coming back as correct. It should be. Ian, you might have to reload the page. Tell me, Ian, if you reload the page, I can correct it if need be. Reload the page. I'm trying to fix this one. I've ran into an error. My brain has overheated. No! Let me see right here. 2 seconds. Brian's brain has overheated. The possible values of x. Okay. So these are possible values of x we're using. And that's being stored into x. I don't think my global environment is hurting this. Possible x not found. Well, that's good that I deleted possible x, you know. Possible values of x are right there. And I don't want to store that. And we're getting that still. Two seconds. Let me see here. More like, let me put 2 minutes on the clock and I'll go back up. Brian's brain overheated. No. This should be the same equation. Ooh, is it a different equation? That would explain the issues. Well, you know what we can do? I think it's the same equation. If something's identical, it'll highlight. It's just that space right there. Spaces don't matter. Oh my gosh, you gotta be kidding me. Do you see it? Wow. I'm sorry, everyone. This is the issue. Do you see it? If something is identical, it'll highlight through, and that is different. So I'm thinking this whole issue I've been having of my graph not coming out the same is because of that. Please be that. It'll be great if it's that. It'll be not nice, but it'll be great. Oh my gosh. Typo right here. No, it should be 3. This is the correct. And now that I've done this and I've created my for loop, I can go here to the which.min of my vector, and we're going to which min of vector cost, and it'll tell me that it is the element in the 119th right here. The 119th is the minimum, or is that the 119th? Oh, actually, this is the value, and I think it is the 119th, but no, that's not the value. Well, now it's looking weird. So let's look at the cost vector. These are the values right here in here. Does it go down that low? Oh, because I see. We want the names. I did this a pretty crazy way. The names of cost are currently the values. Yep, and we want to do these as .numeric. Oh, there's my 2 minutes. I turned this one into a bit of a mess. And it was all as numeric. That's not the minimum. As numeric. Well, that's right. Good, good, good. Oh, is it changed? Wait a minute. Well, if we do these, there's the names as .numeric. Oh, and those are the values. And we do want these right here. We do want the cost. So let's go here to this. Let's go to unname. There we go. Now we got the vector. Much better. Let's call this x. We're almost done. And then which.min of x. 119. It is position 119. The answer is position 119. And 119 is the minimum there. You can confirm it in this area. And now we go to possible x. And the answer is we should use this right there. That value minimizes it. And we can see it over here. Woo! Wow, we didn't get stuck tonight, but this confirms via the graphic. The answer is 0.24, and that's about where it's at. So we want to make sure we confirm the answer and what we're saying makes sense. The 119th possible value of x. And I was just like, no, we can't get this wrong. Neither. And so someone wanted me to go back up to the tips data frame and take a look at that right there. Oh, Brian's brain overheated. A lot of coding today. So much coding. Let's go find that tips data frame. Thank you, everyone, for being here and practicing. If you can't tell, sometimes I need a little practice, too. Make a mistake or two, and the code doesn't work. What did people want to see with the tips data frame? We'll take a few more questions here, then I'll probably head off, answer some questions on Discord. What do people want to see here with the tips data frame? This is the for loop. What questions are you having? A good bit of practice right here. Errors were made tonight. No! The first one got me because it was the code itself. Never change anything in an assignment. Never do that. Talking to future Brian. Is this making sense here, Avery? So this right here is the for loop running it. And I want to say thank you, everybody. Some 50 points right here. It's just you make mistakes and you just try to fix them. That's coding. That is coding. What are people thinking? Can you copy it? Yeah, sure. Why not? Let's copy it to the chat. Will it all copy? It's going to lose its syntax. I think that... Oh. We just can't do the last bit. I think here's thunder outside, too. There it is right there. Just a quick random question. How to exclude a range from a sequence? A range of values? You can subtract them out. You could create like a vector of values. Like, if you want to exclude certain numbers, you go like 1 to 10 and 20 to 29. And now you've excluded certain numbers. So you can see right there we've excluded. You're welcome, Avery. Thank you so much for staying and asking. You just have to practice. You're going to make mistakes. If I make mistakes, you're probably going to make mistakes. Now, you might not. You might not. But I'm still going to make mistakes. So I want to say thank you so much. It's so easy to make mistakes. The thing should be working. I think I updated it. Let me go look at those. Ba-da-ba. Let me go look at these. You might just have to reload. If you got a question right that it counted wrong, just tell me. Yeah, the HP looks correct. And the miles per gallon looks correct. How did I do this wrong? Not that I did this. So those look to be correct now. Please tell me if it's counting them wrong for you. If it's counting them wrong, let me know. How would you do it using the minus sign? You could do like a vector. Let's try this. If you did a vector down here of values you wanted to go through, and you had a vector of like 1 through 50, and you were to go here. Now this would be the values of 1 through 50. And then if you want to subtract out certain values, you could do it with positions, but it's much easier to make it the other way. I'd have to look at the specific question you're asking, because you could go here and subtract out of it, concatenate, subtract out positions 20 through 30. So now we should get everything but 20 through 30 in the vector 1 through 50. If you notice, we remove 20 through 30 in here. So that is one way to do it right there. Take the vector and then remove the positions from the vector. Does that make sense, Mohammed, right there? You could use the minus sign, and then you could also remove out other things. Like you could remove out also the value 50. And now notice we removed 20 through 50 and the element 50. But be careful, though, because if you had a vector that started off at like 20 and went through 100, then you wouldn't be removing 20 through 30. You're removing the 20 through 30th thing in the vector. So it's not removing 20 through 30. You could use witches and stuff like that. It is 3G in the homework. Yep. So you got it. There's this. Does that help right there, Mohammed? How to see how to do that right there? A little bit complicated. I'll same song. So that right there. We'll be doing the homework soon. If you have questions, let me know on the homework. Lots of good practice tonight. Lots of good examples. We got through a lot of this. Woo! Lots of practice. We got through like 60%. That's good. Hour and a half, 60%. Some of them are quick. Some of them are hard. Lots of instructions. Oh, message me, Mohammed. We'll take a look. I'm going to head off here. I'm going to eat some dinner. Probably reply to some Discord. Message me. You can see I've got 9 messages down there on the Discord. So I'll be back here in a little bit answering questions. Let me know if you have questions. It's thundering outside. I will see everybody in a little bit. See you tomorrow if you're in class. Bye for now, everybody. Bye. More coding. We got this. Don't let your brain overheat. Take a break.